Hello everyone, welcome back to my another 6th tutorial of reinforcement learning. So in this part I'm going to show you how to implement one of the most groundbreaking reinforcement learning algorithms, deep Q network from pixel data. After the end of this tutorial, you'll be able to create an agent that successfully plays almost any game using only pixel input. Of course, if you'll be able to train it. In all my previous DeepQNet tutorials, we have used game-specific inputs like card position or pole angle. Now we are going to be more general and we will use something that all games have in common. It's pixels. To begin with, I would like to come back to our first DeepQNet tutorial where we wrote our first agent code to take actions randomly. Now we'll do the same thing, but instead of using specific environment inputs, we'll use pixels. And here I already have a code, so we can open it with terminal or Sublime. And if I'll run this here on Sublime, it works very fast, so I might run it like that to show you how it works. So you can see that poll is showing. So instead of poll, maybe would like to receive some kind of pixel data. So I will write a code instead of environment render. I'll write that I image equal to environment render, and here I'll write that mode is equal to RGB or array. This is documented in gem documentation that this way we can get an image data. So for example, here I can print the shape because we'll need it, and so let's build this. See what we see. Works too fast that we could see, but we can see that output is 400 by 600 and by 3. So RGB is 3 channels. So this short code was playing random games for us. Now we'll need to build our own render, get image, reset, and step functions to work directly with pixel. Using this function, we receive a rendered frame image. This way we'll get our image, and yes, it's sad that we'll need to render every frame of our game. It will be much slower than training without render, but there is no other way to get frame game real station. For example, if I would do this with my, for example, playing some shooting game, I would need to receive an image in similar way as I was doing for my previous tutorial. So we could use different gym environments game where it would give us frame without rendering, but now we'll try real life example like this one, and only next tutorial we'll try some faster ways. So right now you write this code for you, and that it could be similar as it was in our previous tutorials where we used a class. So here I will also need import numpy by npy and import and import cv2. And what I'll need is I'll need to move these down here, for example. So I need to change a view here. So so we'll use indentation as tabs. I found this yesterday. So if, for example, name is equal to what we used here, like this, but like this, equal to main, what we'll do is environment name is equal to carpole Actually, it doesn't matter it's v0 or v1, but I think we use v0, v1 I mean. And okay, and then I'll write agent is equal to deep-Q network, convolutional neural networks agent, and here I'll add an environment name like that, and here I'll just use an environment agent run. Now we need to create our deep-Q network class, so I'll do this simply, and I'll write here a class network agent. Here, of course, we'll begin with define of init and cell environment name. Then we'll need a define image show function itself, and here will be our image shown. Right now I can use fast. That. Then I need define a get image of self pass here. Here I'll write a define a reset self, and of course pass for now. Here I'll use a define run. So as it was before, actually move this tab here, and yeah, and it should be working right now. We'll just here we pass like this works, but instead of pass I'll add here that I'll use environment name will be equal to environment name, of course, and so environment will be equal to gym dot make environment name. Yeah, and here we have we'll need to add self here, and of course here also self image shape here self, and I think that's fine. We can check if it's working, and it can convolutional agent self environment. Okay. Oh, sorry. I and this. Yeah, you saw it played. Oh, here that says that environment is not defined. So we'll go to one more cell to add here, just like that. Of course, image. Yeah, mistake. As you can see, it was playing for a few seconds. Maybe it was only a second, but it doesn't matter. Anyway, this is the structure we need to improve here. So I'll write everything here. We can begin with something like, for example, change this of self, for example, set. And here what we will get, that we'll get an image self dot environment set, and we'll write that it will return our state. And what we'll do is simply we'll write that we would like to return a state, just like that. And instead of reset here, we can call right now our self dot reset. Okay, and we need to write on and define on self image show function. So here instead I will write that cv2 dot imshow. This is only for debugging, we don't need it actually right now, but we can write that our environment name, and so simply we would like to show an image here. and here we need to write 2 weight key, and here is 25, and of course f equal to order of q value here to destroy all the windows and just return. So here we used a render. Instead of render, we can right now write this example. I'm not sure if it will work, but yeah, why not? Image. Okay. Show is not defined. Wiki, something like that. And as you can see, right now we can see our RGB another window which we received here, and we just showed it to us. So right now we would like to do some tricks here with our code. So for our observation, we need to stack not one image, but we need to stack at least 2 consecutive frames. And because we don't have all information to determine what's really going on our game, so we don't have any information about the movement of the game objects, and I hope we all can agree that it's crucial in the world of games. So will be some kind of way to overcome this. So 2 frames, no, it's not enough. So we can see the direction and the velocity of the ball, but in 2 frames, but we don't know its acceleration. So we can stack 3 frames, but it might be still not enough. So we can derive both the directions, velocity and acceleration of the moving objects, but not as where game is rendered at the same pace. So I think we should keep 4 frames just to be sure that we have all the necessary information. So what I'll need to do is that I'll need to work this with my images, and I'll need to remake them. So instead right now I need to work with getImage function here, transfer everything to my getImage function here, and will be like that, and I'll move this. I will show. So we'll use here getImage, and getImage as a result we might receive a state. So state will be self.getImage, and here we'll need to write something. So yeah, we can leave it as it is, but for now we need to convert it to RGB. Image RGB will be equal to C2 CVT color, and here we need my image and CV2 dot color RGB to grayscale. That next we must be sure that our image is exact frame, because later we'll need to input this to my convolutional neural networks. So I can write that it's something like that, and we'll use a OpenCV function of resize, and we'll call it image RGB. So here will be my columns and rows, and of course we'll use interpolation, intercubic, And right now we need to define what is my rows. So here I'll add top.rows will be equal, as we saw our game frames has 160 rows, and need to define my columns. So it was 240. And of course, as I said, we would like to remember some kind of steps. So I'll try to remember 4 steps. And for a random game, we'll play here 10 episodes. We'll change this later. And of course, right now we need to create some kind of array where we'll store our images to store these frames into our history. So I'll creating an image memory, which is equal to numpy zeros, using numpy to get a speed. And here I'll write that we need to remember 4 frames. We use self.rows, and then we use self.columns. So that's it. Now we need to change it here, here, and of course we would like to make it as RGB. So image RGB size will be equal to image RGB size. Then we need to place it to a numpy array. So I will divide it by 2550. And actually, after these 2 steps, we now need to store this to our image memory. So image memory, and it will be equal to numpy row. Numpy row does some kind of similar function as our d2 function was using. It just rolls axis by 1. So now when my axis is rolled, I can store my function here. And what I'll do is here will be my first place, just like that, and it will be equal to image resized. And of course we need a return function here. We'll use numpy expand dims. But yeah, this function will be used to our convolutional neural networks. Right now I'm not sure if we need it, because I can show everything here. So I'll just write a self.imshow function. I'll add here that I would like to see self image memory, and I'll add that I would like to see 0 frame from our image memory. Right now we are not showing any frames here, so we'll need to edit this function. I'll add a remember steps function. Right now it's different, so default will be 0 frame. So I'll add also here something different, so it will show the frame and string remember step here. And I'll add here that we would like to see first step, and of course everything in what goes after this frame. So I think imshow should work, get image should work. As said, it will not work. So what we need to do is we need to make a for loop here. So for I remember steps. So this is that when we start the game, we fill our memory with first frame simply, and because we use the reset only one time. So that's it. And I think, yeah, we don't have a step function, so I'll add this here. Self dot action, and we'll add that this should be quite similar to this. Done info next state word done info, and here what we are seeing was like this. Here we use self environment step action. Here we get a next state. So we would like to get image of that state. So here will be a return, and well, yeah, we need to return here something, and here will be our yeah, we'll receive simply an image, and this way we can do that. We return a new next state, new and same reward, none and info. That's it. So here we need to shape it a little bit. So yeah, expand dimensions here. Use self for image memory, and it will use axis 0, just like that. And I think now we finished. It will return our next state, which will be a little bit different shape. Doesn't matter, we're quite fine here. So now we just need to change something, I think, here. So yeah, we'll do a random action here. So it will be the same, but here we remove that we use self environment, and we'll use self step action. We'll do this same. Yeah, maybe it will work. Instead of this self episode range, self episodes. See how it works. Find self, find 43, find action. Yeah, it shouldn't be a dot. It should be like that. Compile is not defined. Sorry, that's my mistake. And that image is not defined. Here, self get one image, but two arguments are given. State sorry, these my mistakes. That image. No, we don't need another argument here. Actually, not sure. Oh, sorry, this is my mistake. And here it goes. We have an RGB image here. It took a while for us to rewrite everything as we needed, but doesn't matter. Everything is with a good plans. So right now you saw how it plays, and I'll add one more thing here. So for our model to be easier to play, we would like to receive black and white. So instead of image, write that we'll use frames. That this is a very simple type to convert to black and white, but this method only for this game and only for this situation and this tutorial. It doesn't matter for future tutorials because, well, this is a very simple environment. So this code will be uploaded and you can test random games by yourself. It's quite simple. So right now we are moving to another part where it will be much more difficult. So I will merge everything into one code. But before merging everything, one code, we must do one major improvement, implement our convolutional neural networks to our current code. If you are not familiar with convolutional neural networks, I have several tutorials about them. Before moving forward, I recommend checking them out. So first, I'll copy the code from my previous tutorial. And I go here, pull, and I copy it here. I think we also need a prioritize expenditure play memory. I'll copy it and I'll rename it to something like G from CNN. Maybe I'll rename it later to something different, but right now I'll use it as it is. And Sublime, and I'll change our view. So view, layout, and 2 columns. So here I'll use a random, and here will be my main code, so you could see everything more clearly. Sorry if you can't see a full code here, but this way it will be easier to show you how I copy everything. What I do here, I need to add a few more layers, so adding here Latin, convolutional 2D, and activation functions, just like that. It might take a while for me to modify this, so I'll pause the video here and I'll pass the convolutional, or I'll write convolutional layers, so you'll see everything, because this tutorial is not about convolutional layers. So it's quite simple. I only wrote these 4 lines here. It doesn't matter really very much, but now we need to make some changes in our this code where we are defining everything what we need. So here changes our self state size. We will change input state size to my model. So here I have episodes. I can add these lines where I define a input shape to my model. Next I can I don't really mean can, but I should change my model. So now it was using a self state size, and right now I'll remove this because my state size will be a little different. So I can, there's my image memory. I'll add it somewhere here, image memory, and I need a state size, self state size, and it will be equal to my shape, image memory shape. Of course I could change a little, swap them, but doesn't matter, I already wrote this. So right now I need to change my input shape, so I delete this, and I'll change input state size here also. So right now we need to change our replay function because I changed it here. Where's my replay? So in our replay I have a batch size and state size, but instead of this I need to add do it something like this, I think, or I can do this. I'm not I'm not sure right now. I can't remember, but I'm sure it would work like this. In future we'll see. Maybe I can do it a little differently. I'll make a investigation. So we created a state and our next state. So right now we have our following functions. I just copy these step reset get image show functions to here, and now we need to play around with modal run. So here what I'm doing, where I receiving my state. So here I use self environment to receive. Right now I'll use self environment, I mean self reset, and where I do step I'll use my simple step functions, and that's it, I think. I'm not sure, but we don't need to change a lot of stuff here. Okay, I can try to build this, but I prefer building this on this way. So run, and let's see. Okay, we have an error here. Yeah, I need to change our reshape functions. I totally forgot about that. Okay, I'll turn this off. Where's my code? Yeah, I don't need a reshape anymore because I'm doing the same stuff here. We are using NumPy expand dims, where we have more reshapes in test. Yeah, I won't play with test right now, but it can also be worked around. Environment render. No, we don't. We need this. So step environment set. That's the way to play. And let's check this out. Okay, let's run. Name CV2 is not defined. I'm not sure what writes this. Oh, I understood right now. I didn't. I missed an imports. That's true. Okay, import CV2 files. So sorry, I had to kill my recordings because, well, actually it was not necessary to see for you what I was changing. It took me a while, but there was few mistakes and it took me a while to find them out. I don't know how to mark them here, but anyway, I'll post everything on my code on my webpage, and I'll add a code there. It doesn't matter for you, but anyway, right now we can try to run this code, and you'll see that my agent is performing. Okay, we might, if you want to see an RGB image, I also can show this for you. So show, here it is. And here is an image what my convolutional neural networks inputs gets, and we actually train our agent on this input. So now I'll train my model and see you later when I finish training. So welcome back, and I've finished training my model. I think you are really interested how our new agent performs simply with pixel inputs, and I will tell you, not that well as I wanted or expected, but at least we can see that it's working and it was trained. There's a lot where to improve, but we'll see. So the same as before, I trained agent this time for 500 episodes to save my time, but as I told that this time will be saving current and 3 history images. So I did training tests for 1, 2, 3, and 4 history images, and here are the results. As you can see, from this chart, we can see that our agent just with one input performed the worst. Even our random agent could perform in a similar way. So then we can see that agents who have more channels than one performs better, and we can assume that more channels our agent sees, better it performs. But there is one minus. More channel it has, more resources are needed for training. So I tried to train 4 channels agents for longer. I trained it for 1000 steps, and here it is how it performed. So as you can see here, blue spikes are actual scores, and red one is the average of 50 games, moving average. So we can say that our agent reached best performance and right around, I don't know, 500 steps of training, and then it was not improving anymore. Our average game score was around 100. It's much worse than using 4 parameters as inputs than using pixels. But in real life, it's impossible to get best input parameters. They have always some kind of noise or errors. So this was some kind of simulation how we can learn from seeing visualizations from pixels or so on. So I'll try to train another model for longer, for around 3000 steps. We'll see if I will. I'll post it to my website. And right now, that's all. We have just created a smarter agent that learns to play balancing card pool game from image pixels. That's awesome. And remember that if you want to have an agent with really good performance with pixel data, you need many more GPU hours, about 2 days of training. So for some of you, it might be not affordable. But we'll talk about that in future tutorials. But don't forget to implement each part of this tutorial by yourself. It's important to try modify the code I gave you, try to change neural network architecture, change the learning rate, use a harder environment, or so on. Remember that this was a quite long tutorial series, so be sure to really understand why we use these new strategies, how they work, and the advantages of using them. And if you don't understand how everything works up to this point, later to analyze and understand more complicated systems will be much harder. So take your time and try to analyze, understand it right now. In next tutorial, I will cover more reinforcement learning strategies on simple environments, and only when we'll have covered all the most known and popular strategies, we'll try reinforcement learning or more complicated tasks. Because before trying complicated environments, we need to know how everything works to adapt our model to an environment. So that's it to this tutorial. I will upload the code to GitHub on my page. Anyway, you will be able to download and test by yourself. And I think that's it for this tutorial. It was a quite long video tutorial, so I need to stop it here. And I hope this was useful for you, and if you would like to get more this kind of tutorials, please subscribe and like my channel. And of course, see you in our next tutorial. Bye.